Uh, Hello everyone, welcome to the channel. Today we will be solving this problem of the day. Today is 25th Jan 2026. Uh, so let's see how to solve this problem. Today is an easy problem for us. So okay, let's see how it goes. So we are given an zero indexed integer array nums, where nums of I represents the score of ith student, and we are also given an integer k. We have to pick the scores of any k students from the array so that the difference between the highest and lowest of the k scores is minimized. Okay, and we have to find the minimum uh, difference possible. Okay, so if you just imagine the problem statement is that we will be having some array. Here are the elements. Okay, it's up to a6. Now we want to choose any k elements among these. Okay. Okay. Uh, Now we have to choose any k elements such that the maximum of those k elements minus minimum of those k elements must be, it must be less as possible. Okay, they should be as less as possible. So how can we solve this problem? In the previous video, I had discussed a technique like it's not a technique, but it's a workaround. So whenever you see such kind of problems where the important observation is that the order does not matter. Yet also the order doesn't matter. So what it leads us to is sorting. Okay, so let's say first of all, let's sort the array. Okay, then see what happens because we can choose any k elements, right? We can choose, in any order. So let's say that this array is sorted. So let's say if let's say this is the now okay, let's try to fix the first element. Okay, so for let's say we have to choose k elements. Let's say here the k is 4. Now we have to choose k elements. So let's fix this element, like we will be fixing this a1 first. So let's fix a1. Now from here we will okay, let's say we fix a1. Now we want to choose three more elements, right? So which three elements would you choose? Which three will be the best one? If you just observe manually, you will see that like okay, a2 is the closest one, then a3 is the closest one, then a4 is the closest. So you will choose all of these four elements. Okay, when a1 is taken, right, as the first element, when a1 is taken as the first element, it's also the minimum one. Also the minimum one. So what will be the, current difference for this subarray? Okay, you can observe like this is a subarray, right? So if you see, the difference will be just a4 minus a3, right? It will be just a4 minus a1, sorry. And so this may not be optimal. Like let's say here we have 1, then we have 7, 8, 9, 10. Okay, and we had to choose four elements, right? So here we just fix this and take a4, so the difference will be 8, right? But what if now we choose a2 as the first element? So we have to choose three more elements, right? Now we will not check the previous elements because they will always have been checked first. Okay, so they will be checked at the first place. Now, from E2, let's try to pick four elements, right? So the next three elements will be this, this, and this. So of course, the new difference will be 3. As you know, the previous difference was 8. Now the 3 is minimum, so 3 is one of our candidate answers, but 3 is better than 8. Okay. So now what this leads us to, okay? This leads us to the observation that A1 will always be paired up with A4, A2 will always be paired up with A5, A3 will always be paired up with um, A6, right? Just add 3 in them, A4 and A7, right? So for each AI, we want to choose AI plus K, something like that. Okay. I mean, where I plus K, this is an index. Okay. So, and we'll just take the difference and the minimum, right? So let's see how to code it, right? So for each, so let's define our answer as int max. Now, because we want to find the minimum one, and int max is never possible within this constraints. Okay. Answer cannot be int max. So So int max, if you don't know, it's around 1e10, I guess. So that's it. Now we want to choose, right? So first of all, the need is we have to solve the array. Now we just take the size of. Now, if we want to check, right? For each I, there will be the element will be the I plus k element, right? So it in the zero-based indexing thing, it will be I plus k minus one. So our current reference will be nums of I plus k minus 1 minus nums of I. And we just want to, update this um, answer, minimum of answer and current difference, right? And then just return answer. Now here, if you see, this can overload, right? I mean, overflow. So we want I plus k minus 1 should be less than equal to n, and it should be fine. Let's see if it works. Yeah, let's submit it. As you can see, we got accepted. And if we think further, can there be some further workaround? Uh, we can do some workaround because the nums of I is, 1e5, maybe. Maybe we can maintain a hash table and then maintain the previous element, sorry, the next elements into nums only. So that the time complexity will be, I guess, a little bit better. Yeah, that's all for this video. Thank you so much.